All right, so in this video, we'll cover getting to the moon from Kerbin orbit. So right now I have a vehicle that is in orbit of Kerbin, and what you'll want to have is a nice circular orbit like this, where the periapsis and the apoapsis are both roughly equal, maybe within a few kilometers of each other. That'll make finding an encounter with the moon a lot easier, as you'll see in a second here. If this orbit was not perfectly circular, say that you had your apoapsis out here somewhere and your periapsis was closer to the moon, what you could do is wait until you drifted out to the apoapsis and then burned prograde, aka the direction you're traveling, and doing that out there would raise the periapsis out, and then you would stop that burn until you had a nice circle. The reason having a nice even circle is so good, since the moon is going in a circle here, is that I can add a maneuver here literally anywhere to start. What you'll do is you'll add a maneuver, you'll drag the prograde marker out until the planned future orbit is just touching where the moon's orbit is. So I'm going to go out here until that orbit's just touching. Here I got lucky and I actually found right where the moon is. If I would have created this over here, say, you'd create the maneuver until it is just, say, just barely touching that orbit. And then we don't know if the moon's actually going to be there, but we can drag the node itself around like this until we find where the moon's going to be. Generally, it'll be about 90 degrees ahead of where it is now. This particular encounter, I think it's in about 3 days. And this one, I think if we drag over here, there's another encounter we can find. It's going to be in 1 day, because I think what this is showing is that in 1 day you'll drift out and get to the moon. The reason why there's another one over here is because this is actually on a secondary orbit. So you would actually orbit for 1 day, come back, orbit for a second day, and on the third day the moon would actually arrive over there. So we can do either one. Let's do the direct one here, so we have to wait less time to find that moon. And we can see the periapsis is about 175,000 meters currently. That's good for our purposes. You want to be kind of nice and close to the moon. The closer you get to it, when you slow down to try to orbit it, the more efficient that will be. So say if I was like out over here, you could kind of tweak this a bit until that periapsis gets nice and close. So here we have 394. If the periapsis disappears like that, that means you're on a collision course. So be careful that that's not the case. So let's say we got a periapsis here of, let me get my maneuver back, there it is. About 166. I wonder if we can get to 100. Be a little bit closer. 89, yeah. So I don't think the moon has any mountains above maybe like 14 or 15,000 feet. So 89,000 feet will be plenty safe. We can make more adjustments later, but this is fine. All right, so we'll need to circle the planet, and then we'll find that maneuver. And it looks like the burn time will be about 34 seconds. Ideally, the most efficient burns will be like low amounts of time, so like just a few seconds to do a burn. Of course, for something like a moon encounter, you're going to have to, your burn may be a whole minute, depending on how much fuel and how strong your engines are. The problem with long burns is if your burn is like a minute or 2 minutes and you start the burn here, by the time you're done, you'll actually be finishing that burn around here, and your orbit would have been swinging out like over here. You'd probably even miss the moon. So to compensate for that, the best thing to do is burn a little bit early, maybe about half the amount of time early. So my burn time of 34 seconds, half of 34 is, say, 16. No, maybe 17. Yeah, so 17 seconds. What I'll do is I'll start the burn at T minus 17, because what that'll do is I'll start the burn around here, and I'll finish the burn around over here. We'll kind of go through that maneuver as we're doing the burn, and that kind of starting a little early and ending a little late will compensate for the fact that we can't have like a perfectly quick burn. So that should make our orbit as close to this line as possible. All right, so let's go ahead and do that. I'm going to time warp until I'm about T minus, 17 seconds. 17 minutes, 14 minutes, 10 minutes. 4, 3, 2. Stop here because we want to get into our orientation here. I'm just going to point the vehicle at the maneuver node indicator on the nav ball. We'll turn on stability assistance since we've got some reaction wheels on board. That'll keep us centered on this. So now we're ready, and we're just going to wait for T minus 17. We'll time warp a little bit. All right, and hit Z to fire our engines. You could look at it from the map view or from the vehicle view. Either one doesn't really matter. We'll kind of look at this for now. Another way to, if you are playing career mode and you do not have maneuver nodes unlocked, another thing to remember is you could just burn prograde when the moon is rising above the horizon. That is also an indicator that it's about the correct time to do a burn. So if you didn't have access to maneuver nodes, point prograde, start burning when the moon rises above the horizon, and just watch your orbit until it intersects the moon over here. All right, so let's see how we did. We ended up with an actual periapsis of 28,000 meters, so that's significantly closer than we planned. I happen to know that's still safe, so we can get away with that. We'll be nice and close to the moon. And right at the periapsis is where we want to do our retrograde burn. Because right now, if I didn't burn at all, if I just coasted by the moon, this would be a flyby. If we didn't have anything going on, we just coasted on by. The moon's gravity currently would be slingshotting us into this other purple orbit you see, which would be a little bit harder to get home from. But we actually want to stop at the moon. We want to orbit the moon. So right at the periapsis, the closest point to the moon, is the most efficient place to slow down. So I'm going to pull retrograde here until we see the orbit stop to drop. So here we can see that we are entering into an orbit around the moon, or rather where the moon will be. You don't see the moon here right now because the moon's not there yet. The moon's actually back here. We are going to intercept the moon at the same time when it gets to us. You don't need to do this, but if you really want to see a preview of it, you can set your view to focus on the moon itself. Well, it's not clicking for me here. The moon, yes. So focus view. And then we can come in over here and actually see what that's going to look like in the future. So we can just kind of orbit the moon like this. If we really wanted to, we could even drop this down lower to get, wrong direction, no, that was the right direction. I think I was clicking this one by accident. Let's delete that because I think I might have messed that up a little bit. There we go. Let's recreate the maneuver. So right at the periapsis at the closest point, let's pull retrograde until we see that orbit drop down. We're at, 28,000 meters here. And let's drop down. I guess we'll do a nice circular orbit to about, let's see, we're at 62 there. A little closer, 44. Yeah, it doesn't need to be perfect out, I guess I'll go a little lower here. So 35. We can see because this maneuver is not like absolutely perfectly aligned with the periapsis, that will change the position of our periapsis and apoapsis. Some of these other things you can experiment with and try dragging around. I happen to know that if you do these radial ins and outs, those can slightly adjust the position of the periapsis. So we can kind of make a small adjustment like this. So let's see, that's 28. Now 34, we can drop that down to about 28 or so. Yes, that's very close. This is very circular and very close to the moon, which would be a nice orbit if you're planning to do a landing at some point. We also are coming in at kind of an angle. So I don't know if I want to come in an angle like this. It might be better to go around the equator. So we could just ignore that. Come in, do our burn in about a day, and that would put us in an orbit around the moon. I guess I can do something a little bit more advanced here. If you don't want to come in at an angle, you want to change the angle you're coming in at. Let's reset our view here. The most efficient way to change your inclination is actually to do that at the halfway point. So I'm going to add maneuver here. I'm going to focus my view on the moon here so we can preview the path. And if I adjust my inclination back here at the halfway point, up or down, I should be able to adjust the angle I'm coming in at. So now I'm at this perfectly equatorial angle. Unfortunately, that does put us on a collision course. So I also need to adjust the prograde and retrograde a little bit to make sure we don't collide with the moon. There we go. So let's get, so 24,000. It's a little close. Just for, let's go to maybe 40,000. 36 is fine. Yeah, so anywhere in this area is fine. So let's do that maneuver first, and then we'll actually set up the maneuver to get into an orbit. So it's time warp. You can see it's a very small adjustment at this halfway point, 0.06 seconds of burn. So I'm actually just going to really feather the throttle on this. Just the smallest amount of throttle we need. Let's get lined up with that inclination adjustment. Okay, we're centered on the maneuver node. Let's time warp a little bit to that planned point. This one, it doesn't really matter being here exactly, so I can start the burn on this particular one. So I'm just going to tap shift a little bit just to really feather that throttle because it's such a small correction we need. Okay. Now we can confirm that that is more of an equatorial flyby. Let's go focus view. Yeah, so now we're more equatorial. We're not at this weird inclination. So let's set up our orbit capture. So you got 126 and 30 over here. We can also adjust that by dragging this slightly so it's perfectly on the periapsis. Realistically, it does not need to be this perfect, but so 34, 56. But if you're trying to get a very exact orbit, this is how you would do it. $34, $35. Yeah. And I can't really get much closer than this. Realistically, when I do the burn, since the burn's going to take 27 seconds, I'm not going to get anywhere near this perfect in orbit, but this will be a good target to shoot for. All right, so I'm going to line up with that maneuver node. And it looks like we'll be doing that in about 5 hours. So let's time warp a bit. Be a little careful. I could also, instead of using the controls to manually turn time warp on and off, I'm just hitting my period and comma buttons on the keyboard here. I could also do a warp here. So let's see, here's the escape. So we're coming in from here. So let's do that's a little close, maybe right here. Let's warp here. So now we can just kind of let it do the time warp for us. Okay, the warp here is completed. We'll kind of take over manually here. We could start science. I think when you're near the moon, you have 2 different biomes in space you can get science from. There's high science and low science. Low science for the moon starts at 60 kilometers. So when we're down here at 34 kilometers, that's going to be a different area of science we can get than we can get up here at whoever knows how high we are currently. We're currently like 600 kilometers. Is that what I'm saying? Yeah. All right. So we got T minus 28 minutes till the burn. Burn's going to last 27 seconds. Half of 27 or half of 28 is about, 14? So we'll start about 14 seconds early. So we'll do our burn at T minus 14. Seconds, that is. T-minus 2 minutes. All right, we are still lined up on our maneuver node that we set up previously. You can tell it's close to the retrograde indicator. And it looks like I'm only have a tiny bit of fuel left on this stage, so I'm going to have to hit the space bar to stage into the other one relatively quick. So burning, stage out, stage into the next stage. Currently, I only have 2 engines active. That's because I'm trying to save these full tanks of fuel for a landing stage. We'll talk about that in a bit when we do a landing video. I'll upload that in just a couple minutes. And there we have it. We are in orbit of the moon.